We're now going to talk about the inverse trig functions, which you would find on the bottom of page 3 of your Unit 14 packet. First, let's talk about what it means to have an inverse. A function had to be one-to-one in order to have an inverse function, and there was a test that we used to check this in the previous units, and that was called a horizontal line test. So if a line passes through the function and at any one moment in time, if that line crossed more than one point, then we concluded that it did not have an inverse function. So the graph of an inverse function, you'll also recall, is a reflection about the line y equals x. And so what happens when you take an inverse function is you have the original function, and if you switched every single x and y coordinate point and graph that, then you come up with the inverse function. So y and x is a point on the inverse function. Okay, the domain and range of a function and its inverse are switched. So what is the domain of one function becomes the range of the other. We saw that with exponential and logs. Whatever was the domain of exponential is the range of logs, and whatever is the range of exponential became the domain of logs. So taking a look at the graph below there, you see that we have in pink, what is this function that we have right here? Hopefully you guys guessed or saw that it is y equals cosine of x. So I am going to do the vertical line test on, or not the vertical line test, but the horizontal line test. The vertical line test would just show that it is a function, which it is. But if I were to pass a line through this cosine function, we would see that it fails the horizontal line test at multiple points. So therefore, the inverse would not be a function. So it's not to say that you couldn't find the inverse. You could just switch all the x's and y's, and the results of that would be this function right here. So if I swapped x and y or reflected it across the line y equals x, I would get that. And so the reason it's not a function is now if I were to apply the vertical line test to my inverse, I would get that it fails the vertical line test. So the question is, how then are we supposed to study inverse trig functions if the original trig functions don't pass the horizontal line test? So what we do is we can think of it as trick the function itself so that we restrict the domain of the original function so that when it becomes the range of your inverse function, it will pass the vertical line test. So I'm going to ask that you guys have a different color out, and it helps to see this part of it. So let's think back to when we first learned how to graph these functions. And I'm going to trace in blue because I haven't used blue yet. In blue, what the cosine function is at 0. So angle 0, you have 0. And then we mapped the next point over here as pi over 2. Then at pi, it was -1. So if you were to trace this portion out and then ignore the rest of the pink graph, but just look at that piece of the function from 0 to pi, would the horizontal line test pass just that piece of the function? So if I were to pass the horizontal line test through that blue part, it does pass that, which means that the inverse for that blue part does exist. And not only does it exist, but it is also a function. So let me erase the horizontal line test, and then in a different color, I'm going to trace what happens when it gets reflected across y equals x. When it gets reflected across y equals x, we have, let's do red. We have the portion of the function that is, this point gets reflected over here. If you were to fold the blue over y equals x, you get that this point reflects across to the red point right there. And so if I trace out all the points, that would mean that we get this portion of the curve all the way to here, and it just, let me undo that. So all the way to here. Okay, so that red part now, if you were to perform the vertical line test, would pass. So this is your inverse cosine of x function. Okay, and the little negative one is to indicate that that's an inverse. So that's notation for inverse cosine. So there's a couple of ways you guys can call inverse cosine. We see inverse cosine having the little negative one there. Sometimes that's confusing for the reader because they might think that this means 1 over cosine of x, which it does not mean. Some textbooks like using arc cosine of x as the inverse notation as well. So arc cosine and inverse cosine of x means the same thing. So now we're going to go ahead and take a look at the actual inverse functions for sine, cosine, and what it means to have a restricted domain and range. So the restriction part was the blue and the red part. We're going to cut off the rest of it that makes it fail the horizontal line test so that its inverse function does exist. So for sine, if you take a look at the first portion of the sine curve closest to the origin to where it passes the horizontal line test, then this is the original sine function, and I am restricting the domain to be negative pi over 2 to pi over 2. So when I take that and I switch it across and flip it across y equals x, now that becomes the x coordinates, or the domain becomes the range, and then the range becomes the domain of the other function. So I'm going to highlight that in a different color for you guys. So this 1 and this -1 now becomes the domain. So here, this is going to be the domain and range that we are filling out here is going to be of the inverse function. Okay, so the domain of the inverse function now is -1 to 1, inclusive of it. The range is going to be negative pi over 2 is the smallest y value to pi over 2 inclusive as well. And I'm going to refer back to this on the next page, but negative pi over 2 would mean that it can be any one of these values within that range. So negative pi over 2, and it inadvertently made that circle, but negative pi over 2 to pi over 2 would be within this range. So basically, it could be quadrant 1, or it could be in quadrant 4 for the domain, for the range, and it's positive in the first quadrant and negative in the fourth quadrant. Now, if we take a look at cosine, the restrictions on there would be what we had discussed above, 0 to pi becomes 0 to pi for the range. So for the range, we have 0 to pi. What was the range of -1 to 1 is now the domain. So same as sine. If we, on the unit circle, look at 0 to pi, that spans the first and the second quadrant, where the first quadrant is where cosine is positive and second quadrant is where it's negative. So we're only allowed answers within the first and second quadrant for cosine, and then within the fourth and first for sine. Now, our last one that we're going to talk about is tangent. And tangent, the first wave, or not wave, but first cycle of tangent that's closest to the origin that we can restrict so that its inverse exists is between negative pi over 2 and pi over 2. Now, if we had more of it, it would fail the horizontal line test. So therefore, we restrict the domain from negative pi over 2 to pi over 2, which then restricts the range from negative pi over 2 to pi over 2. And this is, again, of the inverse function. The domain was negative infinity to infinity for the original function, so now it becomes the domain of the inverse function, so negative infinity to infinity. Okay, if you think about negative pi over 2 to pi over 2, well, that's the same thing as sine above here. So you can have it in the first, for tangent, inverse tangent, you can have values in the first and the fourth quadrant, where the first is positive and the fourth it's negative. So the restrictions on the domains are discussed below here. And we're not going to graph out secant, cosecant, and cotangent, but there's a way to remember those. For the positive trig, every trig function is positive within the first quadrant. So the only ones that are different are now the negative trig values, and there's 3 functions in each one of the quadrants, quadrant 2 and quadrant 4, that are allowed to be negative. So we've discussed sine being negative and tangent being negative in the 4th quadrant. And so it's easy enough for us to remember that sine and cosecant go together. So those 3 trig functions, or the inverse trig functions, are negative in that quadrant. Okay, and then for the second quadrant, we have cosine and its reciprocal, so easy enough to remember, as well as cotangent. And the reason with cotangent is, if you remember our function, the first wave of it was 0 to pi and going in that direction like that. So to restrict the domain on the original function from 0 to pi meant that we had to restrict the range of the inverse function to be 0 to pi.